Good morning, everyone. Welcome to assignment number 11, which is all about logarithms. Today's lesson, we're going to do it a little bit differently. It'll be more like a class lesson where, if possible, I'd like you to print out the handout that I've attached. And if you can't print it out, then just leave it open in another tab, and you just have to go back and forth between the video and the worksheet so you can follow along. So even though we're talking about logarithms today, you can see that the title of this handout today is called the WhatPower function. So under your opening exercises, part A says to evaluate each expression, and the first two have been completed for you. And then we get to what looks like this, where it says WhatPower with that little 2 with the 8 in parentheses equals 3, and the WhatPower of that little 3 with the 9 in parentheses equals to 2. Now you are going to have to fill in the rest of those blanks, but look at the first two that have been done for you. Can you figure out any relationship or what's going on between that 2, that 8, that 3 in the first one, or that 3, that 9, that 2 in the second one? So I want you to pause the video and think about that for a minute. Hopefully you were able to figure out what was going on there. And you saw, well, we have a 2, an 8, and a 3. And what's happening with these numbers? Well, we have this 3, this 2, and this 9. It might be easier to see in the second one. But you see what's happening is that you've got a 2 raised to the third power is equal to 8. You've got a 3 raised to the second power of 9. So we're saying what power of 2 is 8? And that's 3. What power of 3 is 9? And that's 2. Well, what power of 6 is 36? And that answer is going to be 2, because 6 squared is 36. Okay, so 2 to the third power is 8, 3 squared is 9, 6 squared is 36. So I want you to pause the video. Hold on, Serena. Take a minute and see if you could figure out the rest of part A. So hopefully you completed this section by now. If not, again, just pause the video, try this out first, then unpause it as we go over it. So here we go. We just did what power of 6 is 36, and that was 2. What power of 2 is 32? 5, because 2 to the 5th power is 32. What power of 10 is 1,000 is 3, because 10 to the third power is 1,000. What power of 10 is 1,000,000, and that's 6, because it's 1 with 6 zeros. What power of 100 is 1,000,000? Well, now we're looking with how many pairs of 2 zeros do we see? It's 1, 2, 3, because 100 to the third power is 1,000,000. 100 times 100 times 100. For the next one, what power of 4 is 64? And that's 3, because 4 to the third power is 64. What power of 2 is 64? And that's going to be 6, because 2 to the 6th power is 64. What power of 9 is 3? Well, how do we turn a 9 into a 3 using exponents? Is you got to take the square root of 9, right? And so we know square root is a half. So 9 to the 1/2 power is 3. That's why what power of 9 is 3 is 1/2. Okay. What power of 5 is radical 5? Well, that's going to be 1/2. What power of a half is 1/8? Well, that's 3, because 1/2 to the third power is 1/8. What power of 42 is 1? This one's actually easy, because anytime you have a 1 in here, it's going to be 0, because any base to a power of 0 is going to be equal to 1. And then finally, what power of 100 is equal to 1/100th? And that's -1, because 1 over 100 is going to be equal to 0.01. So if we were in class right now, I wouldn't have told you what the rule is. I would have had you guys break up into groups, turn to your partner or whatever, and try and see if you could figure out what's happening here on your own. But we already kind of defined this, as we can see that when we have what power, this little x down here with the y in parentheses is equal to z, well, that just means that what we're doing is x to the power of z is equal to y. And that's the rule we kind of create for this WhatPower function, is that WhatPower with this base of x with the y in parentheses equal to z just means what we're figuring out is x to the power of z is equal to y. And that's how we filled out that first section. Well, our WhatPower function has an actual name. It is called a logarithm. It's not called the WhatPower function. It is called a logarithm. Okay? And here's what a logarithm is defined as. If you remember, we have a base raised to an exponent. Well, that's equal to a number. So if we have a base raised to an exponent equals to a number, then in logarithmic form, we take the log of base b of some number is equal to the exponent. This is exactly what we just did with the WhatPower function. It's exactly the same thing. We're just not calling it WhatPower anymore. We're calling it logarithm. So to go back and forth, if we, I always say, just think of Ben and Benet, I don't know, and just you're kind of flip-flopping the N and the E. But a base raised to an exponent is equal to a number. Then the log of that number in that base is equal to the exponent. A logarithm is just an exponent. That's why it's in the rules of exponents unit. Okay. A little trick we use to go back and forth between log form and exponential form is called either the spiral or the lasso. Same thing. But what matters is how it's set up. You got to have the log expression on the left-hand side is equal to the exponent in order for the lasso to work this way. So the way the lasso works is we start at our base and we just loop around and point to our number. So we're starting at the base, so the B comes first. And then as we go around the lasso, you can see, oh, we get to the E next. So that's going to be next in our exponential form. And then we get to equals n. So b to the power of e is equal to n because we're kind of looping around. That's why it's called the spiral or the lasso. Similarly, it works in the opposite direction as well. If we have the exponential term on the left-hand side, then we can convert back into logarithmic form by using the lasso yet again. We're starting at b, we're passing through n, and that's equal to e. So it's log base b of n is equal to e. And that is probably the best way to go back and forth between log form and exponential form. So write these two into exponential form. We've got log base 2 of 64 equals 6, and log base 4 of 16 is equal to 2. So the first one, we've got log base 2 of 64 equals 6. Do the lasso. Start at the 2, loop around through the 6, and you're going to end up pointing at the 64. We started at 2. The next number we hit was 6, so that's going to be our exponent. And then we get equals, and then the arrow's pointing to 64. So we get log base 2 of 64 equals 6, becomes 2 to the 6 equals 64. Pause the video and see if you can do log base 4 of 16 is equal to 2. All right, I hope you're able to do it and see that 4, we loop around through the 2 is equal to 16. So it becomes 4 to the power of 2 is equal to 16. You can also just try and make it work out mathematically by saying, well, we got to get 4, 16, and 2 matched up properly, where you're not going to have 4 to the 16th power is 2. Okay? This number down at the bottom is the base. It's the base. So it's always going to be the base of your exponential expression. So we're always starting with the 4, and it's always down. It's a base. Remember, it's like the support, so it's down at the bottom. Okay? And notice how I write the base in this logs. It's much lower. It's much lower, so don't write it in a straight line. You'll see what I mean in the next section when we go from exponential into logarithmic form. So what about going back from exponential into logarithmic form? 4 to the 5th equals 1024, 64 to the 1/2 equals 8, and 12 to the power of 2 is equal to 144. I'm going to do the first one, and then I want you to pause it and try the next two. So here, 4 to the 5th power is 1024. we can do the lasso. But when we do the lasso, you got to make sure your exponential expression is on the left-hand side. Otherwise, you'll just have to do your lasso in reverse. We start at the 4, we pass through the 1024, and we end up pointing at the 5. So this means it's just going to be the log with a base of 4 of 1024 is equal to 5. That's how we write it in logarithmic form. Again, a logarithm is an exponent, so it's always just going to be equal to the exponent. At this point, I want you to pause the video and try those two problems. We've got 64 to the 1/2 equals 8. 12 squared equals 144. So pause it, try to convert those into logarithmic form, and then hit play. So for 64 to the 1/2 equals 8. Start at 64, pass through the 8 equals 1/2. So it's going to be the log base is 64 of 8 is equal to 1/2. Just like that. Log base 64 of 8 equals 1/2. And for that last one, we've got 12 squared equals 144. We loop around, and we're going to have log base is 12 of 144, and that's equal to 2. So now we're kind of back to where we started, just now we're going to use the word log, which is short for logarithm, instead of our WhatPower. So you can see the first two are done for you. Log base 2 of 8 equals 3. The log base 3 of 9 is equal to 2. And you should look familiar, because if we go back, let's see if this will work. Hold on. If you go back, these are actually exactly the same as in our opening exercise. It's just now we're replacing the word log. Here we go. So the log base 6 of 36, what are you thinking in your mind? In your mind, you're thinking 6 to what power is 36? And hopefully you say, oh, that is going to be equal to, well, just that, 2, because 6 squared is 36. And the log base 2 of 32, etc., etc., log base 10 of 1,000. So what I want you to do is pause the video, see if you can fill these out now using log, and then we'll come back, we'll check your answers, and then I'll let you go on your merry way. So here are your answers. For number 3, we've got the log base 6 of 36 is equal to 2, like we just said. The log base 2 of 32 is equal to 5. Log base 10 of 1,000 is equal to 3. Log base 42 of 1 equals 0. Log base 100 of 1/100th is negative 1. And log base 2 of 1/4 is going to be equal to negative 2. All right, so if you have any questions on any of those, again, just shoot me an email. What I'd like you to do is, this is due on Tuesday, April 7th at 8 in the morning, or 7:59 a.m. We're posting the answers at 8 in the morning. I would like you to do number 9, which is compute the value of each logs, which is just the same exact thing we did up here, okay? And then the last sheet, which is what, 12 questions, these 12 as well, okay? So that's what your assignment is. So write them down, take a picture of them, and then send them to myself or Mr. Fallett, depending who you have. And if you can't submit it online, then just email it to us. So there we go. That's the end. Try it. I know it's something that's new that you haven't seen before. I've never taught it online before either. I hope you understood what I did. If not, just reach out to myself or Mr. Fallett. Do your work. Stay on top of it. We'll get through this. Wash your hands. Stay quarantined. We're going to flatten the curve. And be well, everyone. I will talk to you later.